Okay, so the purpose of this video is to help you out with getting started with how to work through an ideal gas law problem. So what we're going to use is our ideal gas law, PV equals nRT. Also, you may hear this affectionately referred to as PIVNERT, because that's what all the letters smushed together looks like. So you're going to practice using this PIVNERT, ideal gas law equation. You're also going to get some practice with dimensional analysis, which means converting between units. So I've given you a temperature conversion here, how to convert between Kelvin and Celsius, and I've also given you some pressure conversions. So when we did our ideal gas law notes, what I talked about was how your universal gas constant, your gas law constant, capital R, this thing right here, can have many different actual numerical values to it depending on the units. We are going to specifically use this gas law with these units, which means that in order to do your gas law problems for this problem set, I want you to make sure that your pressure is in units of atmospheres, your volume is in units of liters, your number of moles are in number of moles, and your temperature is always in Kelvin. So that means if you go through and look in a problem and you see that something is not in those correct units, we're going to have to rearrange our equation, like do some unit conversions to fix it. So let me walk you through just one of these problems just to kind of get you used to how it works, and then I'm going to set you loose with the answer key to work on more. So number 1 says, how many moles of gas does it take to occupy 20 liters at a pressure of 5.3 atmospheres and a temperature of 500 K? So the first thing you want to do is kind of just get yourself situated, figure out what you know and what are you asked to solve for. So in this problem, it says 20 liters, that's a number, so I'm going to highlight that. A pressure of 5.3 atmospheres, highlight that. A temperature of 500 K. So in this problem, I tell you pretty much what each of these variables are referring to. So liters we know are volume, so I'm going to plug that in for volume here with my units. I give pressure of 5.3 atm, 0 atm, I want to keep all those, and a temperature of 500 K, so 500 Kelvin, decimal. That decimal point is critical because now we know we need to report all of our final answers to the correct number of significant figures. So let's get some practice. All right, lastly is going to be your ideal gas constant, and that's not going to change, so we're going to plug this thing in here, 206 liters times atmospheres over moles times Kelvin. All right. One thing that's really important is that if you have a constant, that does not account for your significant figure determination at the end of this problem. So let's first just take a look at this number of sig figs we have in each of our values, because that's going to help us figure out what our final answer is going to be. So in 5.30 atmospheres, I have 3 sig figs. Put sig figs up at the top. There we go. That 0 at the end is significant because it's what's called a trailing 0. 20.0, this one also has 3 sig figs. This 0 becomes significant because there is a decimal 0 at the end, meaning that decimal 0 is a trailing 0 and it is significant. So that 0 in the middle becomes significant. R we don't have to worry about because constants do not count for significant figures. And 500 Kelvin, because of this cute little decimal point at the end, that means those zeros are in fact significant. So I've got 3 sig figs. So this one's easy because they all have 3 significant figures. So I know that my answer at the end has to have 3 significant figures. So I don't have anything about number of moles in here, which must mean that's the thing I'm solving for. And if I go back and look at my problem, it does in fact say how many moles of gas. So that's what I'm trying to solve for in this problem. So now let's check. Do I have to do any unit conversions? I'm in atmospheres, I'm in liters, I'm in Kelvin, and so my final answer will be in moles. So it looks like I don't have to do any unit conversions. Looking good there. Now I have to decide, how am I going to arrange my ideal gas equation? So we know that ideal gas law is equal to PV equals nRT, pivnert. What's the variable that I want to solve for? Well, I don't know n, so I have to solve for n. So to rearrange this equation, I need to divide both sides by RT to get n on its own. So I'm going to end up with moles is equal to PV over RT. Okay, rewrite that right over here. And now that I have my problem set up in the correct format, this should be a fairly easy problem. It's just plug and chug. Plug in all the numbers you've got, make sure your units are exactly what you want them to be, and then put it in your calculator. So my pressure is 5.30 atmospheres. Yes, you do need to write your units in here to show me how they cancel. Volume is 20.0 liters. Ideal gas constant, 0.08206 liters times atmospheres over moles times Kelvin. And temperature, 500 Kelvin. All right, so let's check to see if my units cancel. Atmospheres cancels with atmospheres, numerator, denominator. Here we got numerator, denominator. Here we got denominator, denominator of the denominator. So those things indeed do cancel. If you're stuck on that math for how they cancel, come ask me. And I'm left with inverse moles in the denominator, which means that I'm going to be left with moles as my overall units. So this thing does work out. All right, so once we plug this into our calculator, what we end up with is, do I have a value for this? Oh, no, I'm gonna let you solve for it. I don't have my calculator handy. So you're gonna solve for this and then you're gonna check the answer key. But don't worry, I'll have the answer in the answer key once I go find my calculator. So number of moles, there you go. So remember, this is basically how you solve any of these problems. Just list what you know, write out the ideal gas law, rearrange it to get the variable that you want, plug in everything that you know, and then put it in your calculator. Easy peasy lemon squeezy. The only thing you have to be careful of is if you happen to have something that is not in the units that you want. Hint, 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 hint. You have to do a conversion to make sure that you're in those units that are in the universal gas constant that I want you to use. All right, get some practice.